I'm Fred Streitz, the Chief Computational Scientist at Lawrence Livermore National Laboratory and the Director of the High Performance Computing Innovation Center. Welcome to the IBM booth. It's interesting to see more and more people now talking about this convergence of machine learning and AI technologies with hard simulation, what's being called here HPC, but I call predictive simulation. We've been doing that now for a couple of years in a project that I lead that's a collaboration with the National Cancer Institute. Now, you may say to yourself, Department of Energy, why are you working with the National Cancer Institute? So I'm a physicist, not an oncologist, but they have the domain science expertise. They understand the cancer problem they're trying to solve. What they don't know is how to do that on a giant computer. Well, we're the Department of Energy. We have giant computers, and we also have a small army of people that actually know how to use those giant computers. So it's a natural partnership to develop some of the capability that's going to be needed to address cancer computationally using some of the brightest minds that understand cancer. We're using machine learning to actually guide the decisions that are made about what simulation to run next, because it's a very large space. You can't model everything, even with the computers that we have. How do you most efficient, what's the next best simulation to run given everything you know? And then once you run that simulation, what's the next best simulation to run given everything you now know? We're doing that in a closed loop on Sierra. And that was a partnership, a capability we created in a partnership with the National Cancer Institute and with the researchers at IBM.
Hi, my name is Dr. Rosemary Francis. I'm the CEO of Ellexus. Ellexus is the I/O profiling company, and welcome to the IBM booth. So Ellexus is the I/O profiling company. We make tools to help people understand the way they access data. So I'm here to meet with customers, to meet with partners, to form new alliances, and to make the world of system telemetry a better place. So our customers actually use HPC in a bunch of different ways, and what's really interesting is they really stretch the definition of HPC. So plenty do traditional HPC and have large jobs running across many machines, but we also have customers with very, very small jobs doing high throughput computing, potentially with lots of users and lots of jobs sharing single machines. The machine learning workloads are different again, where you've got what looks like a very large job spanning potentially hundreds and thousands of nodes, particularly in cloud environments, but all doing the same thing with no intercommunication. So what's really interesting is we see lots of diversity in the applications, lots of diversity in the I/O patterns and compute. I think always with system telemetry and with profiling, there's a big challenge in trading off the amount of data you get and the overhead and management of that. You don't want the tools that help you do your job to become a job. So making sure that you've got the infrastructure in place and the communication in place and the processes in place to do something good with that data, now that it's being collected, I think is really important, and it's something that companies and organizations are starting to address. So in terms of the move to the cloud, that brings a ton of really interesting challenges. A big part of what we do is actually in migration stage. So understanding your workload starts with what files do you need to move to the cloud. It then moves on to tuning for the cloud and selecting the right storage platform. Now, with the flexibility in the cloud, that brings a lot of challenges. You have to get it right in order to get the cost trade-offs to work. And it's not always going to be the right choice for every single workload. So selecting the right workloads for moving to the cloud is a key part of what we do, and really important for our customers who are looking to get the most out of their on-prem infrastructure as well as exploit the resources in the cloud. In terms of AI, I think that's a really interesting challenge for HPC. Comes with very different I/O patterns, very different compute patterns, and so it is going to shape the availability of hardware and the availability of software systems around us and for the industry. I think they bring a lot in terms of scale. So the scale that you get for AI systems is going to be a really interesting challenge for HPC that we perhaps have only seen in systems for weather forecast and such really, really big applications like that. So education is very important. As a company, We help administrators educate their users in their efficiency of the system when there's good I/O and bad I/O. From a personal point of view, I'm involved with the Raspberry Pi Foundation, and we've just had a very important announcement that every child in England will have a computer science education and will learn to code as delivered by Raspberry Pi and their partners. That is absolutely game-changing, and a lot of that material will be available for free worldwide, and so that is going to change the world, starting with the next generation. Thank you for stopping by. We hope to see you next year.